All right, we're going to do carbon tetrafluoride today, the Lewis dot structure. I'm going to do the abbreviated drawing, which is all that you need for today's worksheet. But we're going to go over the steps. First, we have to know ionic or covalent. I see that I have prefixes. That means it's covalent. So I'm going to have sharing bonds. If it was ionic, it would be the crisscross, or the shipping them together, and those ones are plus minus bonds, where we have arrows and brackets. Okay. Covalent prefixes. What's the other thing that I know that's that it would be covalent? If you see hydrogen, he's going to form covalence. Why? Because he only has one electron, so he is more stable in a covalent bond than in an ionic bond where he'd give away his very only electron, because he won't have a full crown if he loses that. All right, so carbon tetrafluoride is covalent, so we're going to follow those covalent rules. Step 1, find the central atom. How do we do that? By drawing the element Lewis's. So I only have two elements, carbon, tetra means 4, fluoride. So I only have carbon and fluoride. You don't have to draw 4 fluorines to decide if he's in the center. Draw the Lewis dot of carbon and the Lewis dot of fluorine. If you forget how to draw the Lewis dot, remember the code is here. 1, 2, 3, 4, 5, 6, 7, 8. So carbon would fill in the first 4 spots. Fluorine would fill in the first 7. How do I know? Because carbon's in group 14, so he has 4 valence electrons. Fluorine's in group 17, so he has 7 valence electrons. All right. So we need to see who has the most bonding sites, and that's the boxes. Okay, so for every empty spot, so fluorine has 7 filled and an 8 is empty, he has 1 bonding site. Carbon has 4 full, and then he has 5, 6, 7, and 8 are empty. So he has 4 bonding sites. Fluorine, 1 bonding site. Well, if I want the guy in the center to be who draws us all together, that's why he has to have the most bonding sites. So carbon's going to have the most bonding sites. Now there are 2 exceptions when you're working through the worksheet. Hydrogen, 1 dot. Oh, sorry, let me draw it the way you see. Hydrogen, 1 dot, group 1. He only has 1 bonding site. So he's an exception. Okay, and why is that? Because hydrogen maxes out at 2 electrons. 1 bond site. So he is never going to be in the center. He can be with his partner, H2, or he can be with somebody else, but he's not going to be in the center because he can only do 1. So he can only have 1 partner or be on the outside. Who's the other exception? Boron. Boron's group 13. Okay, so he has 3 electrons. Okay, so you're like, oh great, he has 5 gaps. But every gap has to have a pair with an electron because they have to share 1 electron from boron, 1 electron from somebody else. 1 electron and then a spot for somebody else. 1 electron, spot for somebody else. These guys would not have partners, so there is no bonding site there. So boron is another exception. He only has 3 bond sites. Those are your 2 exceptions you're going to have to worry about today. So when you're finding the central atom, draw the Lewis dots, figure out how many boxes, that's how many bond sites. The one with the most bond sites wins. Okay. Place the central in the center and place other atoms around. Right? So we have carbon in the center, and then fluorine, 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 fluorine. We have 4 fluorines. Okay. Now, we have that. Step 3, single bond from center to each outer. Okay, we call that outer because they're on the outside. Okay, so it's carbon bonds with that fluorine, carbon bonds with this fluorine, that fluorine, and that fluorine. He had 4 bonding sites, so he could make 4 bonds. That makes sense, right? Okay. Now, don't bond fluorine to fluorine because they're not in the center. The bonds only go from the center to the outside, center to the outside, center to the outside, center to the outside. So now we have our first starting part of the structure. Okay. Add valence electrons as needed to make original dot number. Okay, so these bars here are bonds, but what they really are basically, I call them dumbbells. Okay, they are showing the sharing between the electrons. So this carbon has an electron and it's sharing with 1 electron of fluorine. Carbon, 1 electron, sharing 1 electron of fluorine. Carbon has an electron, sharing with 1 of fluorine. Carbon has an electron, sharing 1 with fluorine. And you can also thinking about it as the 2 electrons are holding hands. That's how they're bonding. Okay. So that single bond, so anytime you see a bar, that's 2 electrons. It's a single bond. Okay. And it is sharing. Okay. So now we got to add electrons to get up to our correct valence number. Carbon has 4 valence electrons. Does he have 4? 1, 2, 3, 4. Yes, carbon valence electrons are correct. You want to write that out. It'll become important, especially tomorrow. Okay. Fluorine has 1 valence electron. Each fluorine only has 1 valence electrons, but how many are they supposed to have? 7 valence electrons. So we got to add till we have 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So I'm adding it to make the original dot number, the original dot number. Okay. Now, did you notice I'm not following the pattern anymore because I'm in the molecule. These 2 electrons count for the 2 electrons on the left side. So they count for 5 and 8, even though 5 is fluorines and 8 is carbons. We just have 2 still showing on that side. We have 2 at the top, 2 at the right, and 2 at the bottom. But don't just magically put them in. Make sure you're counting. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Why do we need all those? Because we can't magically create electrons at the end. So fluorine still has to have all of his valence numbers matching. Every single time, check and make sure you didn't magically create any electrons, because it might mean that you put the center atom in the wrong spot. Or you use Google. If you Google this guy, he doesn't have these outer electrons on it. That's 0 points. Don't do that to yourself. Make sure you check the valence numbers. And then the next step is the level up step, okay, which we will be doing tomorrow. But you want to check octet. Okay. What's octet? Everyone should have 8 their own electrons, plus their shared electrons, except for hydrogen, he can only have 2. Okay, hydrogen does not work on the octet rule. So let's check the octets of carbon. Carbon has 1, 2, 3, 4 of his own, and he's borrowing 5, 6, 7, 8. So he has 8. You could also count it 2, 4, 6, 8. Carbon meets the octet. How about fluorine? 2, 4, 6, 8. Okay, so that fluorine met it. You can also count this way: 2, 4, 6, 7 for what they originally had, and 1 more for 8. 7 for what they originally had, plus 1 more for 8. 2, 4, 6, 8. All the fluorines make it. Check every single atom to make sure you don't have a mistake. And then you're going to just rewrite it, this time without showing the dumbbells. Okay. There is, in the slides that you watched, the procedure where you had to show the full process. This will also count as the full process. So if the ovals did not make sense to you, then you can use this process. You absolutely have to check valence and octet to get credit on your work. So on your work, find the central atom, place the outers around, give everybody a single bond from the outer to the center. Do your valence electrons, check your octets. Make sure you have this little quality control, QA/QC, on your table so that I can see that you physically went through and checked it. Okay. Now, if you're struggling with this, watch some more videos, but the least you could do is you could find the central atom for every single one. You could place the central atom in the center and place the others around it. So at least when you turn in your worksheet for today, numbers 1 and 2. But watch some videos, see if you can get all 5 done. And we'll do multiple bonds tomorrow.